right, let's focus, please.
Yeah, exclusive.
All right.
I think so, yeah.
Hey, focus. We're going to talk about area under a curve. All right? Now, what you have learned so far is just a sine area. We haven't really talked about the physical area yet. So we really need to think about the difference between sine area and physical area. All right? So, for today, you should be able to distinguish between the sine area and physical area. You should be able to define area under a curve as an area bound between the curve and the x-axis. Determine the area under the curve problems whereby fx could be greater than 0, could be less than 0. It could be both greater and less than 0, and from an interval a to b. Alright? Now, you should think about when you solve problems like this, you need to find the roots. The roots will tell you what the boundaries are. And then let's explore the use of absolute value functions to obtain the correct physical area under a curve. Class fact. When you do questions like this in exam, always use class fact. If it is in the count assume section. Alright? So now, let's do this definite integral. What does a definite integral tell us? So, yeah, the sine area, because if you plot this, you actually have the positive and the negative area from 1 to 3.5. See? This bit here is positive, this bit is negative. So you can see that if you do the definite integral, it is actually, the numbers that you gave is actually a positive number. This actually is bigger than that, and that is a sine area. So, the area under the curve means that the area bound between the curve and the x-axis. And this time, for physical area, we need to assume that it's positive. Alright? Now, the location of the roots will indicate how to deal with positively and negatively sine area, so that the physical area under the curve can be calculated. Let's think about this situation again. You see somebody's phone. The roots here. That is telling me above there, there's a positively sine area. Correct? And anything that's below that, the roots, from the root onwards, there's a negatively sine area. Yeah? So you need to think about how you can change the negatively sine area. Make sure that it's positive so that you are actually adding both of them together. That will be your physical area. Alright? Definite integral, you add up the positive and negative sine area. You can end up with a positive number or negative number. Physical area, you add up the absolute values of the areas. So it is the actual area bound by the curve and the x-axis, bound by a curve x. Alright, this is the curve and the x-axis. Now, I've given you the interval a to b. So from here to here, this is positive and this is negative. But we must make sure that when we add them together for the physical area, this is the absolute value. Alright? And we refer the physical area as the area under the curve. Now, the area under the curve, we can evaluate it using this. Now, this sign here, I'll elaborate it a little bit more. That just means that if this is negative, which it is, we have to change it to a positive value, which is the absolute value of this number. Alright? So that just means absolute value. I'll elaborate on it a little bit more in a few minutes. So, if you integrate that, you will get this.
So it's like
173
it's getting the positive area
over 24. You want the positive area.
I'm going to separate it because if you just do it.
So if you do a definite integral, this is positive, this is negative. So it will be less than that number. Alright? Now, the roots. I can say the roots actually tell us where the positively signed area is and where the negatively signed area is. I will talk a little bit more about absolute value in a few minutes. Now, determine the area under the curve of x minus 3, x plus 2 over the interval minus 1 between minus 1 and 4. How are you going to do this? You don't know whether the area is positively signed or negatively signed.
You know the roots.
You know the roots, but can you use the roots?
Can you what?
I would suggest you sketch it. Alright? If you just do it this way, minus 1 to 4, it is going to be incorrect because you'll get a negative area. Whereas, if you sketch it this way, just a sketch. For me, instead of sketch, I did this on my laptop so I could just use the program. Now, what you need to do is quick sketch. So when y is 0, x is plus 3, or minus 2. And you know this is a parabola, a U-shaped parabola. So you can see that this is minus 1, this is 4. You will have a negative area and a positive area. Do a quick sketch. Always do a quick sketch. This is my advice. Alright? Now, once you've done the quick sketch, you do know that you can actually take the absolute value of this. And then, even though it's negative, you'll have to take an absolute value of this, and it will be 56 over 3 plus 17 over 6, which is 43 over 2. Alright? So, the important thing, the lesson you have to learn from here is always sketch the curve if you are not provided with the sketch before. Always do that.
If it's negative, you just change it to positive.
Alright? Always do that.
So that's why you're doing it for the
That
negative.
is what I would advise. I'm pretty sure all the other teachers will do the same thing as well. Sketch the curve. Alright? That's one. Try number 2, please. Now, the thing is with this, you really don't know what is the area bound between the curve and the x-axis. So what's the first thing you need to do?
Roots.
Count 3. See, count 3. There. Not past that. Count 3. Roots, yes. Find the roots and then sketch. Factorize it, find the roots, and then sketch.
Wait,
so let's do it first. I'll let you do it.
So where's the bounds? There's no bounds here.
No, there's no bounds here. That's why. You have to find the roots. It's where the roots are.
So
And close between the curve and the x-axis. So you need to know the roots. So it's that area.
Okay.
So this is something like this. I'm pretty sure it looks something like this. All right.
But then it's like infinitely
Yes.
negative and then
Yes,
infinitely
that's
positive.
right. That's right.
It's just
Enclosed. That's no bounds.
infinite.
So it's the area enclosed between the curve.
It means like this, right? It's enclosed. It's inside.
All right.
The outside.
What,
You never know it.
what is the root? One of them would be 0, won't it?
It's a cubic. Yeah, you just do it.
Because they're factorizing the x up.
Yeah, mate. One. So there's 3 roots actually.
I have some count 3 example, and then we're going to use the calculator for a few.
Wait.
4, 5, 6, we'll use the
Sad, bro.
calculator.
It's okay, bro. We all have bad tests.
What are the roots?
I have bad tests. You have bad tests. Everyone has bad tests.
Oh, bad test only 18.
Now, I sketch it first before actually, I know what the roots are.
Nah, you will. You're capping, bro.
So,
you will.
you need to know the roots before you can sketch it.
As long as you don't no cross.
Alright, so this is the area enclosed. So you need to know the roots so that you know you can find the area enclosed between the curve and the x-axis.
Easy.
So the root should be,
But I'm actually, I'm gonna get a neck. I'm gonna actually neck myself.
There's no going back.
0, 1, and 3. Alright? Once you have done that, can you please work out the area, please? You need to be able to show the integration. Alright? So, you know this is a positive, this is a negative area. So you can integrate between 0 and 1, and then 1 and 3. Although this is a negative area, take the absolute value of it and add both together. Question like this will be a tricky one because they don't give you an interval. They expect you to know what the area enclosed is. And therefore the roots, knowing your factorizer, how to factorize, knowing how to find the roots is actually very important in this situation.
No.
So this is how I did it. I integrated from 0 to 1 first, and then I integrated from 1 to 3. Or you can just write out one straight equation with the absolute value, that's fine. Should be doing your methods rather than thinking about something else, alright? What about the spec? Yeah, yes, you got to know this. Alright, so I integrated 1 to 3. I know it's a negative area, but I added the total area. I should have put down unit square, alright? I was a bit lazy, I didn't do that, but I should. Once you integrated this, that should be the same. It's just different values, that's all. You definitely cannot integrate from 0 to 3 because that is a definite integral. That will give you the sine area.
Why is this count free? Why is this count free?
Because it is cal free, because I wanted it to be cal free.
So much brains.
Come on, it's not that bad.
3 times 6.
Alright, one more cal free example. Alright, try this please. This time you can see that for cos, I have to specify the interval from -pi to pi because the area enclosed, there are too many. It's a sine wave. It's therefore you've got too many enclosed area. I really need to specify this.
Yeah, 81, yeah. Alrighty.
You should know how to integrate cos x. We'll give you. Yeah, positive sine x. Absolutely right. Yes. I mean, again, it's a good idea to sketch the graph so that you know. Now, you see, if you sketch a graph, sometimes it makes life a little bit easier because You know that it's symmetrical. Cos is actually symmetrical. Therefore, the area here should be the same as that area. Correct? Yeah? So you can work out one area and multiply by 4, or you can work out this and then that and then this. It's up to you. But sketching does make life a little bit easier. One, you can visualize it. Number two, you know where exactly you're looking for, what the area you're looking for. Which one is positive, which one is negative. Like I say, this should be the same as that. And that should be the same as that, that should be the same as that. So drawing the graph actually helps you visualize and understand what you should do. This is calc free, this is not calc assume. You're not supposed to use calculator for this one. Next, I'm going to show you how to use a calculator. I assume that all of you have a class back? Yeah? Good. Once you know how to use the class back, life is pretty good in a way. Alright, so you can find the roots if you want to. It really doesn't matter. I did that because I just, if I need to plot it, I know the roots is minus pi over 2 and pi over 2 and on and on and on, but I just did that. Alright, so drawing that, pi over 2 is when that equals to 0, that's between that arm. Alright, so the roots is there, and more, but within the bound of minus pi to pi is minus pi over 2 and pi over 2, that's all. So therefore, you can integrate from minus pi to minus pi over 2, which is actually minus 1. I did integrate between minus pi over 2 to pi over 2 as well, but in fact, if you actually look at this graph, you know that the area is straight away 4 times 1. That's it. It is actually up to you. So I did say that this is the same size as pi over 2 to pi, therefore it's minus 1 as well. And then I integrate between pi over 2, minus pi over 2 and pi over 2 and get 2. And then the total area is just 4 units. Alright? Now,
Negative.
if you're happy with this, we'll move on to the next bit using the calculator.
Sick.
Alright? Now, let's have a look at the calculator. I will go through it step by step with you, guiding you with your calculator as well. Y equals to x squared minus 3x minus 4. Alright? Let's go to graph and table, everyone. Alright, I want it to be between 2 and 5. Alright? Go to your class back. Grab your class back, please. Everyone got your class back? With your class back, go to graph and table and actually go edit clear all, please. Make sure that you clear everything, including the graph. Alright? So clear everything, please. And under y1, type in x cubed minus 3x minus 4. Alright? Tap on that and draw it. Did I get the right equation?
Yup.
Yeah, okay, I got the right equation.
Okay, 24.
I think I was going to make it plus 4 to make it easier to see, but Let's see. Nah, let's make it minus 4, that's fine. Alright, that's fine. Alright, now, I want it to be between 2 and 5, alright? You can't really see the graph, so you need to try to zoom in. Let's try auto first and see if it works. Yeah, it is, but then you've lost quite a bit of it. So, if I want to go back, let's go to X min and X max. Let's Y min, oh, that's a bit too much. Let's go to minus 100 to 100. See if you can see. Yep. You can sort of see clearer, but you still need a bit more. Let's change that again. I want X min to be 0. This one to be 6. Alright. No, not that good. I want it to be between 2 and 5. So let's go to max. Alright, so you must make sure 1, 2, 3, 4, 5. You must make sure that when you draw this up, it should meet there. So I may not have enough. I might go a little bit bigger. 150. Click OK and see. Alright, from there, let's go to analysis. Analysis, GSolve. Now, under GSolve, you've got integral. I want you to look at this integral. And you're going to use the integration dx. Don't worry about the root yet. I'll talk about the root in a few minutes. Let's do the first one first. Just tap on that. Alright? Once you tap on that, you'll come up with this line. What you need to do is tap 2. So if you type in 2, it will come up with the lower bound and upper bound. You want 2 and 5. Oops. And 5. Alright? Press 2 and 5 and then click OK. And see, it will work out the area for you. Alright? Now, is this going to be the right area? Is this going to be the right area? Hey? You've got a negative area because under, I think there's a negative area. So, before that, let's do an analysis and look at the root first. Go to the root. See, the root is 2.1959. The root is 2.1958233. All right, write it down. So, what you really need to do in this case is go to analysis, GSolve, go to integral. So you're going to start off with 2 to 2.195. 2 and 2.1958233 and tap OK. Now you've got a negative area. You've got a negative area here, negative 0.2037 or 02. Just write that down. And then you do your integral between GSolve, integral between 2.1958233 and 5. Alright? And that one okay? And you've got an area which is 108.9537. Alright, so you can sum that out. Take the positive value of that, and it's 109.1574. So it's about 109.15 units square. Alright? So you have to look at the graph, and you've got to determine where the roots is. The roots will tell you which area is negative, which area is positive. Then You integrate, use your calculator to integrate that little bit here to get your negative area, and then from here to get your positive area, absolute value, and add them together. Alright? So are you all alright with that? No? Yes? Sorry? No? Alright, let's do it again. Go back. That's fine. Let's go back again. Start off with clear everything. So I don't want to clear it because I want that to be that area. Alright? So you do know that you need to find the roots first, so that you know which is the negative area, which is positive area. Right? So you know that the root is here somewhere. And to find the root, you go to analysis, GSolve, root. The root will give you 2.1958 or 2.1958233. Alright? Because this is actually between that number. So you need to do it twice. The negative bit here, you need to find the area of the negative bit here, which is integrate from 2 to 2.1958233. That, yeah? You get a negative number? Yep, you get a negative number, you convert it to positive. And then you do the integration of 2.1958233 to 5. And then you get a positive number. You add them together. Alright?
And so I was kind of asking more, how do you actually do the initial solve for the area?
Solve the area, let's do it again. So let's start off with analysis, GSolve. Let's start doing the first one. Alright? So integral that. Now, you will come up with this line, which is somewhere here. What you need to do is type in 2. If you type on 2, it will come up with this box here, where you can put in your lower bound. Lower bound is 2. Upper bound is 2.1958233. And when you tap OK, here, this is the area. This is the area. Alright?
What is the lower and upper bound?
Lower bound and upper bound, which is the lower bound and upper bound.
Wait, so what button do you press to get to the upper and lower bound thing? So,
You just, once you got it,
I've got the root,
just type 2. Just type 2.
Example 2.
Analysis.
Did you do it? Example 2.
Yeah.
Just type in 2. It will come up.
You get what you got?
Yeah. Alright, just type in 2. Alright? So this is how you do it. You have to do it twice to get the values. Alright? This number dx here is the area, is the definite integral.
That's that.
So you've got to change that to a positive number. Got it? Yeah?
You have the. So you have the.
Yep. So you go to analysis, GSolve, integral. You go there.
I can't you just find the
1, 2.
root between 2 and the root and the root?
What is the upper bound? Because you need to know the
Yeah.
roots. You need to know the roots. You know this bit here is negative.
Yeah.
Alright? So you need to start from lower bound to 2.19583.
You have a negative area.
And then from 2.1958233 to 5. So this will give you a negative area.
How did you get to
does that root?
You got to find the root. You got to start to find the root with the.
So one root is 2 and one.
Oh, I get this.
No? No. We are going to look for the area for that. But one of the root is here.
Yeah.
So you need to use your calculator. Go to analysis. GSolve. Go to root. It will give you the root set root.
Past the root.
Okay. So you know that the root is between 2 and 5.
Yep.
Alright? So this bit here, between 2 and 5, you know that this bit is a negative area. That bit is positive area.
Yep.
So you need to integrate the negative area first so that you get the negative values and take the absolute value. And then you take the from the root to 5,
Yep.
and then you find positive value. Alright? Okay? Alright, let's go to the next example. Now, before you do the next example, I've got a few things that you need to. Oh, okay. Try this, please. Try this one. Calculate the area enclosed between y equals x cubed plus 3x squared minus 2 over the interval minus 1 and 1. This is calc assumed, so use your calculator. Use your calculator. Alright, use your calculator, please. Clear everything first. So this time is x cubed plus 3x squared minus 2.
Sleep so early.
You have spec though, so you got to study.
I'm sleeping early.
Like, how did you see last night?
Y equals x cubed plus 3x squared minus 2, and the bound is between minus 1 and 1. Alright? Now, you should get this. This is what you should get. And you know that one of the root is minus 1, but you don't know this root, do you? You need to find the roots so that you know you want from here to somewhere here. You've got a negative area, you've got a positive area. So you need to be able to work out this area plus that area. Alright? Of course, if you do straight away from analysis, G-solve, integral, minus 1 to 1, you're not going to get the right answer because that includes a negative area. See, that area is negative. Alright, this area, I don't know what it is, I don't know, but both of them add up to be negative 2. So you know that this is not correct. You have to find the roots first. If you go to analysis, go to G-solve and root, it will start off giving you one root, and then you just need to use your cursor to go to the next root, which is 0.7321. Alright? You must be able to find the root first. If you don't find the root, you will not be able to get the right answer. So therefore, you need to integrate between minus 1 to one of the roots, and then from the other root to 1. Alright? Not only do you have to use your calculator, you must write it out properly. In the exam itself, you've drawn that, you are still expected to find the roots, you're expected to write your integral and your substitution. Alright? This is what I would expect you to write in the exam, not just the calculator. Write it clearly what the roots are, write the area, integration, and finally the answer, 2.5 units squared. I mean, if you really use your calculator, oops, this is it. But you really can't do it this way. You cannot show your screen in the exam, so therefore you must always write it out properly. Alright? Write it out properly so that whoever is marking your paper knows that you know what you're doing. So if you input something incorrectly, there could be follow-through marks. Alright? So yeah, you can. I mean, this is a cheating way of doing it. I did it that way. I show my definite integral. I know more or less the area that I want, and then I look at the roots and then work out the area. But advice, always show the integrals that you have used to obtain your area. always show the antiderivative of the function in square brackets with the bounds. Alright?
Unit square.
Alright? So I didn't really substitute it. I just used my calculator and worked out. Strictly speaking, you should show your substitution like 0.73205 to the power of 4 and so on and so forth. Alright? And then a clear final answer with units. That's what you need to do. Alright. Now the next bit. This time, if you have roots, you want to find it between roots. This is something you probably haven't learned before. If you find between roots, let's see what we can do. Alright? This time, you are going to use this integrate between roots function. It's not always the case, but you can. This time, I'm going to show you the roots. So, we are looking at y equals to sine x. Alright? For between minus pi, x, and pi. Alright? The interval is between minus pi and x. So if you use your calculator, make sure that it's in radians, alright? Go to clear off. Clear off. Alright, clear everything. And go to y equals to sine x. Sine x. Alright? Once you've done that, draw the graph. Draw the graph. And then this time analysis, go to GSolve, integral. You want it between roots. Alright? You've got one root here. So C class pad automatically goes to that root. But you want between minus pi and pi. So it's not this root you want. Let's go to tap on the cursor. Go to the next root. So I want it to be between here and here. So from here, I tap execute. See, I know the solid line tells me that this is a starting point, lower bound. And then let's go to the one. This is x equals to 0. I want that. So I tap no executes again. So here you can see that it's given you the lower bound 3.142, the upper bound is 3.1416. Alright? And then the integration, the definite integral is 0 and the area is 4. Yeah? So you can see if you want in between roots, you can use the integral with roots, which is.
Does it give you the physical area, not the sine?
Yep, it does. See, that is the physical area. That.
Oh. So we can't
That-
use this to find the sine area.
Sorry.
We can't use this one to find
Oh,
the
that's
sine.
0.
Yeah, the sine area is 0. That's the definite integral. 0.
Oh, but that
That's a
one.
definite integral, and that's a physical area.
Wait.
That's a sine area.
Wait, which
Force
is
area.
for the area? Wait,
That's the area.
how is it the area? Isn't it 3 plus?
No, it's not. It's not full.
It's from minus pi to pi,
Yeah.
and there's a.
Oh, okay.
All right.
Oh, you choose.
Yeah, I choose from. This time I choose from pi to pi. So I go to analysis, GSolve, integral, roots. All right. You can go for from here to click exit, execute. So you got 4 of those areas, which is 8. All right. So with roots, it's a little bit easier if you want to use your class back.
Really nice.
All right. The last example.
No, but
Now-
you don't do that in Newtown.
Here, have a look at the absolute value, please, because I'm going to show you how to use absolute value with integration as well. So the absolute value of any values is positive of the value. So minus 5, which is the absolute value of minus 5, is equal to 5. All right? Now, you can use your class pad. I'm lazy. I'm just going to use class pad straight away to show you. You know that the definite integral, listen, you know the definite integral is minus 1.25, yeah? and you know that this is actually a physical area of 1.25. Now, what we can do is we can change the function. We can change the function by actually putting it in the the absolute function in your class pad. All right. See this bit. Yeah. So this bit, the absolute function, this bit has gone up this way, and this bit has all become positive. See? That's how it's changed. So you could actually plot it. I'll show you what to do. Class pad again. This is a trick that you can learn from class pad. Alright, you go to your class pad. What was the function? I can't remember.
3x minus x to the power of 3.
3x minus x to the power of 3. Alright. So let's clear everything. Clear everything. Now, y equals to, watch please, clear everything. Go to your keyboard. Under your keyboard, this little thing here, math 1, this one, this button. Math 1, this one, is absolute value function. Absolute value, 3x, take away x cubed. Alright? Click execute, and then you can see that it's given you as an absolute function. And if you type draw, this is what you get. Yeah? So absolute function just means that it switches it from negative to positive. Now if I want to draw this without the absolute function, see, that is the one without the absolute function. You can see that this bit with absolute function, this bit has been reflected and it's gone up to positive. This bit has been reflected and it's gone up to positive. Alright? Now, last bit, can you try this please? I'm going to be lazy, I'm not writing it out, but I would expect you in the exam to write it out. For this example, I'm just going to show you the graph, that's all. Use the absolute function. Use the absolute function to find the interval minus 1 to 1. Alright? So if you go to your class pad, do not plot that, just plot this. Absolute function analysis, resolve, integral, it's minus 1 to 1. And see, you get the area, it automatically gives you the area as positive. Now, you get the area as positive now. Right. Just press -1, you'll get it. All right. So this is what you get. It's very -1 to 1. Now you should, strictly speaking, write everything out, like I say, step by step. But I was just going to show you what that's all.
How do you do that?
Thank you, sir.
Makes life easy.
Yes.
Now that you know the absolute function, it makes life a lot easier. All right. So that's all I have for you today. I've uploaded some exercises in Google Classroom.